Here is a video on how to enhance a toy-grade RC car. There are several steps one can take to make a RC car faster, have better handling, and look different than how the RC vehicle comes from the manufacturer. It is often said that only hobby-grade RC cars can be enhanced or altered. This video is proof changes can be made to toy-grade RC cars as well. The RC car I am showcasing in this video is a 2006 Chevy Camaro concept released in 2009 from Jada Toys. The RC car was purchased on year of release, but sat in my closet until 2022. Initially, when I purchased the RC car, I did charge the 6-volt battery it came with and raced it around, but I felt the car was too slow and I didn't have the tools to enhance or alter anything on the RC car at the time. I got back in the hobby of RC cars in 2022, so this toy-grade RC car was on my project list. Most of the RC modification videos that exist on this subject usually have the entire toy-grade electronic system removed and replaced with hobby-grade modular components. I wanted to maintain the original toy-grade system and enhance the RC car around those original electronics that came with the RC car. The first thing you want to focus on is the weight of the RC car. Fully disassemble the RC car as much as you can. Remove all screws, clips, and mechanisms that keep the RC car together. Once you have all parts disassembled, figure out ways to remove extra weight from the RC car. Completely review all parts of the car and analyze what parts the car doesn't need to hold the RC car together. Using various tools, remove, cut, or shave off parts the RC car doesn't need to fully function. Removing weight lightens the load placed on the throttle motor and may allow the car to be faster. Once you have all the extra weight removed from the RC car, figure out a way to change how the RC car's body is mounted to the chassis. This will allow for the body to be removed from the chassis more easily for future enhancements. You will no longer need a screwdriver to remove the body from the chassis. I have two sets of configurations I set up on my example here. This Camaro body has a magnetic mounted setup. I also have a body post set up for future bodies if I ever decide to make a change. Once a new mounting system is set up, the older screw-in system can be cut or shaved off to make room and remove weight from the RC car. The receiver antenna on this RC Camaro was hot glued into the top of the body and did not have the external antenna or antenna tubes you see coming out of some RC cars. I built a platform on top of the main PCB board to house the receiver antenna and aimed the end of the antenna vertically toward the roof of the Camaro body. The battery box door on the bottom of the chassis was secured to the chassis via a Phillips screw. This is an inconvenience when out racing and I want to easily replace battery packs. The installed Phillips screw was replaced by a custom-made hand twist screw for easier access to the battery box. If your RC car comes with hard plastic wheels with faux tread like this Camaro did, apply thin rubber tape or grip tape to the tire surface where the tire contacts the driving surface. This will give the RC car more speed, better handling, and less drift on smooth surfaces. For more output, speed, or power, raise the battery voltage by a little bit. One additional cell shouldn't cause any damage to onboard electronics. If your car takes 7.2 volts, try using an 8.4 volt battery or the nearest size LiPo battery like a 2-cell 7.4 volts LiPo. The Camaro we are enhancing here came with a 6 volts battery pack, so we raised the voltage to a 7.2 volts battery. I would not recommend going past one additional cell though, as the more voltage you push through the electronics, you could burn up the PCB board or throttle motor. In addition to raising the main input voltage to 7.2 volts, I installed heat sinks to the 4 MOSFET transistors on the main PCB board. This will help keep them cool due to the additional voltage and current running through the circuitry. The steering and handling mechanisms has also been adjusted or altered. This RC car had a suspension system where if the right front wheel strut had to adjust or move, the left front wheel strut would move in the same direction and vice versa. I split the suspension so each front wheel could move independently, similar to the suspension on a hobby-grade RC car. The turning angles and turning radius has also been adjusted by removing turn limiters to allow for sharper turns. As previously mentioned, the original full-function steering motor is still in place and not replaced by the proportional steering servos seen in hobby-grade cars. Maximum control distance has also been upgraded significantly by changing the length of the transmitter antenna. The original telescopic antenna was 5 sections and 20 inches long. The upgraded telescopic antenna is 7 sections and 38 inches long. Being that this RC car was released in 2009 and still using a 27 MHz transmitter, When compared to the Dumbo RCX6 2.4 GHz transmitters I use for my TT02 RC cars, the distance achieved is impressive. In closing, I have to admit I really did enjoy these upgrades, most especially in transmitter performance, sharper turns, and more speed. I wish I had a way to measure the new speed versus speed before the changes. The RC Camaro from Jada Toys isn't nearly as fast as my Tamiya TT02s running a torque-tuned 540 motor and Hobbywing Quick Run ESC, but it's definitely not as slow in a straight drag as it was out of the box. I hope you try these steps on your next toy-grade RC car purchase. This is Fly the Cool Guy signing off until the next one.